In the last class, we have started with these two architectures. One is CISC and other one is RISC. And we have talked about RISC architectures. RISC stands for Reduced Instruction Set Architecture, where each instruction executes in one clock cycle. And they are very simple instructions, whereas CISC stands for Complex Instruction Set Computer. These are the two architectures present today. And coming to CISC, this architectures, this instruction set is very complex. Complex in the sense it takes longer time in terms of clock cycles to execute these instructions. The reason is most of the instructions, they access the memory. So in one clock duration, the data is to be copied from memory location to the local register and perform in the next clock duration, perform the operation in ALU or equivalent execution. In the next clock cycle, the results may be stored back to the memory location. This is not the case with RISC, where we use load store instructions to access the memory, to get the data from the memory, and store is used to write the data results back to the memory. And in between all the instructions, the CPU access only to the registers. CPU can talk only to the registers. It won't talk to memory directly, right? That is not the case with CISC. One instruction, all the instructions, they can talk memory, they can talk to the memory directly, right? So CISC instructions are complex in that sense. They take longer time in terms of machine clock cycles to execute each one of those instructions. And the main idea behind having such instructions is to reduce burden for the assembly programmers. If you are an assembly programmer, then if you write the code for a given task, it takes just 10 lines to complete the task. Let's say if you write the same code, if you write the code for the same task in RISC or for RISC mission, it takes 40 lines or so. So it reduces the complexity or burden of the assembly programmer. With that intention, these CISC missions were made. Today, we don't have to bother about these things because that burden falls on the compiler. Now it is compiler's capability to decode all these instructions. Next, we will see the features of CISC architecture. To simplify the computer architecture, CISC supports microprogramming. Microprogramming means if you have one instruction, let's say add first it has add, let's say A, B, C. A is address of the memory location. B is also address of the memory location, another memory location. C is the destination address, that is also address of the memory location. Now this add instruction, add A, B, C, where A, B and C are all these three are address of the memory locations. Now that add instruction has to fetch the data present in the memory location A, and that is to be added with the data present in the memory location B, and the addition is to be performed in ALU, and the final result is to be stored back to the address present in the C, right? So if that is the, like this, we have instructions in CISC architecture. If you want to perform all these things, if you want to execute that instruction in one, what is the first step we have to do? We have to fetch the data present in the location A. What is the next step? And store that into one of the registers, local registers within the processor. What is the step 2? We have to fetch the data present in the location B to one of the registers present in the processor. What is the step 3? Add the data which is present in local registers like R1 and R2 in the ALU, and the result is stored back in one of the registers, and in the step 4 or step 5 we have to move the data which is present, that is the result, back to the memory location C, right? So we have to do all these things, but programmer is not writing the code for all these steps. If you are writing code for RISC mission, you have to write like this. You have to write code for step 1, you have to write code for step 2, you have to write code for step 3, you have to write code for step 4, you have to write code for step 5. Whereas in CISC architecture, if you just write add A, B, C, where A, B, C are memory locations, the CPU itself takes care of all these things, and it has also programs, it also has instructions to execute add instruction. They are called micro instructions. They are stored in micro programmed memory. There are two ways of implementing micro programs. One is by storing those in RAM. The other one is hardware implementation, by building circuit to execute all those things. Otherwise, you can store the instructions in the form of bits in RAM. That is also another one. So that's why this CISC architecture becomes slower. Let's see, CISC have more number of predefined instructions. It has so many predefined instructions like add, multiplication, mult, and so on, which makes high-level languages easy to design and implement. CISC consists of less number of registers and more number of addressing modes. Generally 5 to 20 addressing modes it supports, whereas it has very few registers. In RISC architecture, we have plenty of registers, 30 to 40 registers, whereas in CISC architecture, we have very few registers, internal registers, which are very close to the processor. They are present within the processor. Next. CISC processor takes varying cycle time for execution of instructions, multi-clock cycles. That's why we said the instructions are complex in CISC architecture. It takes many clock cycles to execute instructions, and also the number of clock cycles needed to execute instruction will also vary. There are simpler instructions which may be executed in 1 clock cycle. There are complex instructions which may need 3 to 4 clock cycles or even more. So that is the case with CISC. If it is a simpler instruction, that may be executed in 1 or 2 clock cycles. If it is a complex instruction, that may take 5 clock cycles. If that is the thing, then it is difficult to pipeline such architecture. If there is a varying clock cycle instructions, it is difficult to optimize the time. That is, it is difficult to make pipelining for such architectures. Because of the complex instruction set of the CISC, the pipelining technique is very difficult. It is difficult to implement pipelining in CISC architectures. Just now we have seen, if there are instructions, let's say CISC has 200 instructions. Out of 200, 20 instructions are 8-bit wide, or the 20 instructions take 1 clock cycle, 50 instructions take 2 clock cycles, another 60 instructions take 3 clock cycles, another 50 instructions take 4 clock cycles. Like this, depending on the instruction that is being executed, the clock cycle may vary. If that is the case, it is not that easy to build pipelining with such architectures. Now, CISC consists of more number of instructions, generally from 100 to 250. So CISC has plenty of instructions, 100 to 250. This many instructions we don't find in RISC architecture. Special instructions are used very rarely. Although it has so many instructions are used very rarely. Operands in memory are manipulated by instructions. There are instructions. By using those instructions, we can directly access the memory. And whereas in RISC, there are only 2 instructions which directly access the memory. What are they? Load and store. For this reason, it is also called load store architecture. Next, advantages of CISC architecture. Advantages of CISC architecture. Now, what are the advantages of CISC architecture? Each machine language instruction is grouped into a microcode instruction and executed accordingly, and then stored in these are stored inbuilt in the memory of the main processor, termed as microcode implementation. Microcode can be implemented in 2 ways: by storing these micro instructions in separate memory called RAM, or you can build combination circuits to implement these microcodes. It is called hardwired control unit. It is called, if you do this way, it is called hardwired. It is called hardwired, and it is noticed that hardwired control unit is faster than storing the microcode in the RAM. Today, almost all the architectures are hardwired only. Each instruction is made a combination circuit. To execute each one of those instructions, they have a specific combination circuit. As the microcode memory is faster than the main memory, the microcode instruction set can be implemented without considerable speed reduction over hardwired implementation. Actually speaking, hardwired is faster than this one, microcode memory. Actually, in the microcode memory, what we do is, it is basically a memory where we store the microcode instructions. And to fetch those instructions, it takes a little bit time compared to hardwired. Hardwired is nothing but implementing those instructions by using combination circuits. Later we will see some later we will see the main differences between hardwired and this microcode memory implementation of the microcodes in a detail. It is very important. Next, entire new instruction set can be handled by modifying the microprogram design. If you do it if you implement micro instructions by storing in the memory, you can very easily change such microprograms. See, because we are using memory to implement the microprograms, depending on the requirement, we can change such micro instructions because they are stored in memory, ones and zeros. If you want, you can alter it. Whereas if it is a hardwired, you cannot alter it. Once you build the combination circuit in IC, you cannot change it at all. And CISC offers both. You can implement microcode either in memory and also in hardwired. If you choose to implement microprograms in memory, then you have this advantage. Entire new instruction can be handled by modifying the microprogram design. If it is hardwired, then it is not possible. CISC, the number of instructions required to implement the program can be reduced by building rich instruction set. You can have many instructions, thereby the instructions required to implement the program can be reduced. But that is not the problem today because compilers handles that one. Drawbacks of RISC. Drawbacks of RISC. The amount of clock time taken by different instructions will be different. Due to this, the performance of the machine slows down. You cannot implement pipeline that effectively, so that slows down the machine performance. The instruction set complexity and the chip hardware increases as every new version of the processor consists of subset of earlier generations. You have to make your process so that it is able to process the older instructions. So your instruction set increases, means your instruction set complexity increases. Accordingly, you have to have new hardware and so on. You have to have new hardware to support the older instructions. Ultimately or eventually the hardware complexity increases with CISC. Now this is the problem. Only 20% of the existing instructions are used in a typical programming event. So most of the time we are using only 20% of the instruction set. 80% of the instructions are used very rarely. Then too we keep it in the instruction set. So if you are having instruction set, unnecessary instruction set, for each instruction for its execution, you have to have hardware. Without proper hardware, you cannot execute all the instructions. So we are unnecessarily having 80% of the hardware, but it is very rarely used. Next, in this table we have presented, we have written all the differences. This is the CISC. These are the CISC properties, and these are RISC properties. Whereas this one is the parameter. Based on what parameter the CISC is superior or RISC is superior. Now let's see the characteristic that we are looking here is instruction size and format. In complexes in CISC instruction set, in the CISC, all the instructions are having the same size? No. Large set of instructions with variable formats. Some instructions are 16-bit instructions, some of them are 8-bit instructions, some of them are 32-bit instructions, and some of them are 64-bit instructions. Whereas here, small set of instructions with fixed format. Almost all the instructions are 32-bit instructions in RISC. Second parameter, second characteristic is data transfer. See, in the CISC architecture, the processor can access the memory. All the instructions in the instruction set, CISC instruction set, they can access the memory. Memory to memory is there, means you can have add instruction which talks to the memory directly. That is not the case with RISC, where these are the only instructions which can access the memory, which are load and store. Register to register. Most of the time, all the instructions, add instruction or sub instruction or multiplication instruction or any instructions like that, they talk to the registers, not to the memory directly. Whereas here, many instructions can talk to the memory. That is not the case with RISC, where the ALU is connected only to the registers directly. It is not connected to memory unit. Next, CPU control. Most microcode using control memory, but modern CISC use hardwired control also. So just now we said to fetch the data from one location and store that into one of the registers, to fetch the data, second data from another location and store that into second register. This is one, these are two steps. Like that we may have 5 steps or 6 steps to execute one CISC instruction. See, although we are writing just add ABC, where ABC are memory locations, internally we have to have instruction to execute each of these steps. Those instructions are called microcodes. Those microcodes can be implemented by storing the instructions, their opcode in RAM, or they can be implemented by using hardwired. Hardwired means by using combinational circuits. These are the two options before us. And in the earlier days, people were using memory to implement these microcodes. Today, people are also using hardwired control. Hardwired control means implementing those microcodes using combination circuits. Mostly coming to RISC, mostly hardwired without control memory. All the instructions are very simple. You can use directly hardwired. You can very easily implement this hardwired. It is not that easy to implement this hardwired. It takes a lot of space. CPU size increases in CISC because these are complex instructions. Since these are simple instructions, you can very easily implement such instructions directly in the combination, in terms of combination circuit. You don't need RAM and so on, because although it is RAM is one option, we always choose to have this hardwired control in it, because hardwired control unit is faster than RAM counterpart. Next, instruction type. Not register based instructions. See, these are not register based instructions. Many instructions, they take the operands from memory. They take the operands from memory, whereas here all the operands are coming from the registers. Operands are the registers in RISC, whereas here they are memory locations. Like it is valid operation in CISC. Add A, B, C, where A is one memory location in the memory, B and C are also memory locations in the memory. The operation, the instruction add, adds the data present in memory location A to the data present in memory location B, and result is written back to memory location C. That is how instructions will be in CISC. Whereas in RISC, it is register based instruction. You will not have add, you will not have instructions like add A, B, C, where A, B, C are memory locations. You will have instructions like add R1, R2, R3, means the data present in register R1 is added with register R2. That is, result is stored back to R3, where R1, R2, R3 are not memory locations, they are internal registers. Next, memory access. Memory access, more memory access, less memory access. Many times every instruction talks to the memory. So this processor has to access the memory oftentimes, more frequently, whereas less memory access. Once we fetch the data from memory to local registers, then we don't need to access the memory several times. So less memory access, that is one of the important characteristics of RISC. Next, clocks includes multi-clocks. It takes many clocks to execute instructions. Includes single clock. In one clock, you can execute that instruction because these are simpler instructions. Instruction nature, instructions are complex. Complex, just now we said. Instructions are reduced and simple. Simple in the sense, in one clock you can, that instruction will be executed. In one clock, that instruction will be executed. To execute this, you have to break down that instruction into several small codes called microcodes. Okay, it takes a lot of many clock cycles to execute this instruction. That's why we are calling this complex instruction set.